Hello friends, welcome to my channel. Today we are excited to talk about a fundamental concept of computer science, the producer-consumer problem. Have you ever wondered how multiple process or threads efficiently share resources in a computer system? Which is done by using producer-consumer problem. It's a classic synchronization between more than one process. Let's start our session. There is our producer in producer-consumer problem. Producer is producing some items, whereas there is one consumer that is consuming the item produced by producer. The same memory buffer is shared by both producers and consumers, which is a fixed size. Conditions should be followed during this. The producer should produce data only when the buffer is not full. In case it is found that the buffer is full, the producer is not allowed to store any data into the memory buffer. Data can only be consumed by the consumer if and only if the memory buffer is not empty. In case it is found that the buffer is empty, the consumer is not allowed to use any data from the memory buffer. Accessing memory buffer should not be allowed to producer and consumer at the same time. This producer-consumer problem can be solved by using semaphores. Now, what is meant by semaphore? A semaphore is an integer variable in S that, apart from initialization, is accessed by only two standard atomic operations, wait and signal. From the above definitions of wait, it is clear that if the value of S equals 0, then it will enter into an infinite loop because of the semicolon after while loop. Whereas the job of the signal is to increment the value of S. I'll explain the code line by line. These lines include necessary header files for input and output operations and dynamic memory allocation. Here, the program initializes some shared variables. Mutex, this variable is used to control access to the critical sections, producer and consumer functions. It is initialized to 1. Full represents the number of full slots in a buffer. It is initialized to 0. Empty represents the number of empty slots in a buffer. It is initialized to 10. X, a variable to keep track of the produced items. The producer function is defined here. It enters the critical section by decrementing mutex by 1. It increases full to indicate that an item has been produced and added to the buffer. It decreases empty to show that there is one less empty slot. It produces an item, increments X, and prints a message indicating the item produced. It exits the critical section by incrementing mutex by 1. The consumer function is defined here. Similar to the producer function, it enters and exits the critical section using the mutex variable. It decreases full to indicate that an item has been consumed from the buffer. It increases empty to show that there is one more empty slot. It consumes an item, decrements X, and prints a message indicating the item consumed. In the main function, variables N and I are declared for user input and loop control. A menu is displayed to the user with options for selecting producer, consumer, or exit. This loop continuously takes user input and processes the selected operation until the user chooses to exit. Here, the code enters a switch statement based on the user's input, N. It checks whether the user chose to produce an item and verifies if it's possible to produce, considering the mutex and empty conditions. If it's possible, it calls the producer function, otherwise, it prints buffer is full. The case 2 section is similar but for consuming an item. It checks the mutex and full conditions. If the user chooses to exit, case 3, the program terminates using exit 0. This program implements a simple producer-consumer scenario with synchronization to ensure that producers and consumers work together safely. The critical section controlled by mutex guarantees proper synchronization. This is the output of the program. Thank you. If you any doubts, please comment.